Hello, my fellow YouTubers. What's going on? Adam in the house. How you been, buds?
Dad, giant cockroach in the kitchen.
All right. Me too. All right, we got some peeps here. Had to run an errand real quick. Let's see, where do we start? Anybody have any questions before I start rolling into this? The switch. You mean the knife switch up there? Diagram coming soon. I still have some more components to build. I got an oscillator that needs to be built. Then also we're going to be getting rid of remember the commutator segment area? Oh yeah, thanks for the links. So we're going to get rid of that. That's going to be a transistor RAN for that. And what we're going to have to do is, I think on Tuesday I'll have some time. And what we're going to do is we're going to set up a system here to where we're going to have a frequency determining device, and that'll be my oscillator over there. And then we're going to set up a feedback. The new toy, huh? Yeah, we'll get into that new toy in a sec. Then we're going to set up a feedback, and the feedback is going to be set up like the Tesla coils, to where one leg of, I'm going to tap in the one leg of each one of these, and that'll be a feedback into my 2N3055 transistor. So that transistor will fire the coil array based on the resistance up top there, the resistance wire. And I wanted to start off with, let's go over this LC tank circuit that I have here. And I guess you can ask yourself, why am I even adding the LC tank circuit? Well, let's go over this LC tank circuit and see how it works, and then you can figure out for yourself why we're adding this tank circuit to this system. Well, so I have the your inductor. We're feeding the night switch with my SIG gen right now, okay? That SIG generator right now is set at 1 hertz, okay? Can you guys see that? 1 hertz on the SIG generator. And what we're going to do, throw the knife switch, and what you're going to see, the results you're going to see is these 2 LEDs. So the way I got this set up is 1 resistor. Call the LEDs resistors, okay? So we're coming out of the knife switch with the positive side of the signal generator for that, and go into the inductor, out of the inductor bottom, and we're going into the bottom of the capacitor as well as the other LED. So one resistor is off of the inductor and the other resistor is off the capacitor. So right now we're going to go ahead and we're going to hit this with 1 hertz. And let's go ahead and throw the knife switch, and you're going to see that they're out of phase. And what I want to do is this illustration. And why do you think they're out of phase? Well, the reason they're out of phase is because the capacitor and the inductor are basically a mirror image of themselves. So when the inductor is filling up and building a magnetic field, the capacitor is collapsing. And when the capacitor has collapsed, then the inductor charges up the capacitor, and then the capacitor is charged up, and then the inductor collapses. So when the light's off over here, the inductor collapsed. When the light is off over here, the capacitor collapsed. So this is a great way to show you guys how a simple tank circuit works, and how the inductor and the capacitor are a mirror image of himself. Like right now, you can almost say this is a pendulum. That one, bam, the other, bam. So they're just switching back and forth. And this is the basis of how we're going to design the oscillator tank circuit, which will be over here, which will be with these out this one here for something else. So let's go ahead and let's change the frequency. Let's get out of the thing. It's strength. It's back on. You guys are back. Hopefully you heard every word I said. So if you look at the 2 lights, you'll see there's like a swoosh going by. And with that being said, we're going to change the wave now. So we're going to come out of the sine wave. Well, let's go up to 2 hertz. All right, there's 2 hertz. So right now we're banging 2 hertz. Okay. And we're still in sine wave right now. Sine wave, and let's go over to square wave. So you're going to notice one difference now with the lights. And look how the lights are. You're not seeing compulsive hits. Now and go up hertz, 4 hertz, 5, 6. Oh, there goes your tank circuit. Your mirror image capacitor and your inductor. And you can see how the two are working simultaneously next to each other. And they're both doing pretty good here. All right, so now let's go ahead and I'm going to switch it over to kilohertz. So now we're going to go ahead and switch over to kilohertz. So right now we are going to go about an AM station. Oh, those are staying on. Huh. All right, we're back in the hertz. I wanted to show you guys how it is reliable enough to use for a charging, and right now you have no pulses or anything going into that tank circuit. Let's go ahead. We want me a magnet over here. Now notice I put over here PMH, okay? These magnets are real strong, so they're hard to even get off. You can see me peeling them off. All right. I was doing some tests to see if I would be able to somehow create a wave with magnet. So on these here, that's what I'm working on here. It's the same principle as the Dragon wave here. Is a sinusoidal back and forth. Once this segment is running, there's enough power there to be able to run stuff, and it's just like a motionless generator. So we'll be working on that. But this right here was kind of a backsided concept that I had, that if I could somehow reverse the poles on the magnets, by pulsing them. So today I did some experimenting. If you take a couple turns of wire and put it over the magnet and pulse the magnet, you can flip the poles. I'll just go with that. So a lot of work needs to be done over there with trying to get a magnet to do something different than just be a constant. So the other fun thing is that we have here is this guy. Now, I'm waiting for another part to come in, but this is a 3-phase motor for a washing machine, and we're going to throw a 3-phase in it. And I'm going to buy 2 of these. Why did I buy them? Well, it seems pretty interesting that they have all these spools, and they also have magnets on the inside. And I just need the right setup for them. I did notice one thing, that people out there on videos that are using these always talk about how much torque they have. So let's fool around with that torque and see what we can do. But until I get the rest of the parts pretty much just gonna be here working. I got a couple jobs this week that I have to do, so I'll be in and out of the shop. My birthday on Tuesday, so I don't think I'll be doing any videos on Tuesday. Turning 56. Let me see what else going on. Excited about this. This is pretty interesting. That whole tank circuit. I know it's not like revelation of anything great, but the way it works is just phenomenal. It really is. So touch base with me. I'll be doing another pop-up video on Wednesday. I should have my other parts in for that motor. We'll get that motor turning. We'll fudge with that. I'm working on this guy over here, so we'll get that commutator solid state system running there. We'll get that producing, and then we'll start digging that apart and seeing exactly what it's making and how we could enhance it and make it more efficient, and see where we are on the on what current it has, what volts it's putting out. I mean, we already seen a teaser on it putting out 130 volts AC and DC. So it was like 80 volts DC, 130, 140 AC, which kind of sounds right. And then from there, I like to see, you know, what kind of current. And I won't know any of that until I get past the commutator issue that we had. But you guys take care, man. Peace out. Leave your comments.